Hi there, and welcome to this webinar. Thank you so much for joining us. The topic today is how to automate deployment of ML code in AWS. I would just first like to point out that if there's any questions or anything you wonder about, please feel free to drop us a line in the chat and we will try to answer your questions right there. Okay, let's just get started. So, your host for today is myself, Mia Ryan. I'm a sales specialist in analytics and cloud solutions. With me today, I have Yngve Sandal. He's a AWS Solutions Architect. Both of us, we work with machine learning platforms in the cloud. So the agenda for today. So this topic is about automated pipelines for machine learning, but in essence, this is DevOps. So just to be sure that everyone is on the same page, I'm just going to explain a little bit about what is DevOps and what is CI/CD. Furthermore, why could you not just put ML code into the existing type of pipelines of CI/CD which exist today? And furthermore, how to do it. After that, Yngve will do a little demo on how to do this in AWS. I just have to tell you a little bit about who we are. We are Redpill Linpro. We are the leading open source service provider in the Nordics. We've been doing this for about 25 years now. Have offices in Norway, Sweden, and Denmark, and we are about 175 people. What we do is actually what also leads up to this webinar. We're quite heavy on the cloud. We work a lot with AWS and also with our own sort of open source Redpill Linpro Nordic Cloud. Another kind of core element of what we do is DevOps. That's kind of very close to our hearts. So when we started doing analytics architecture, it was quite natural to try to bring the DevOps principles into the analytics as well. So other than that, we do integration and we do development and architecture. So that was a little bit about us. I'm going to now tell you a little bit more about DevOps and CI/CD. And the most easy thing here is to explain what was before DevOps, when you have development and operations in two different teams. When a software developer had made a piece of code that he or she wanted to deploy into production, they would just throw it over to operations, who had the responsibility of doing that and checking for like security and other stuff. The problem was that the software developer would do this on their own environment, like their own PC. And when you're supposed to deploy this into production, it was a completely different environment. So there was a lot of bugs. And there was also a lot of blame games on who was responsible for this. The answer to this was DevOps. So I'm not going to sit there and talk about so much about DevOps and the culture and agile and all of that, because that could take me, the whole week. What we are focusing on is the sort of the technical grounds for it. What is the enabler for doing DevOps? And the enabler here is continuous integration and continuous deployment, CI/CD. The common CI/CD build is when you have a developer that works, for example, in GitHub, in AWS Code Commit, or in, for example, GitLab. It could be anything, just a Git repo. You build your code and you want to get it to deployment. What is good about the DevOps pipelines is that it actually enables your developer to put your own code to production. And what it does is that when you do a Git push from your Git repo, you build a container. In this container, you have all the sort of what does your code actually need to work in production, and of course the code itself. This container and with the code is then tested. And when I said tested, it's more to the type of is the code semantically correct, like unit testing and code review. If this checks out, it's deployed to production. So by this, the software developer gets self-service. If they want to change something or there's a new feature coming, you could just roll that out yourself. If there's something wrong, just roll back and then change it and roll out again. This gives you the what's called waterfall versus agile. So this is in the agile land. You can do several iterations, and we have customers that does up to 1,000 different changes in one day. Whereas before you would have this waterfall thing, and you would work on a piece of code for maybe months or even half a year. And you would have this big deployment after a while, and it would always be buggy, and there would always be problems. Here you have smaller pieces of changes, and it's a lot easier to just get this out to production. However, trying to implement the ML code into this kind of pipeline is not, you can't really do it directly. And the reason for this is, of course, machine learning code is statistical code. It's not sort of software code. And first and foremost, it's not really easy fail or pass. A software developer doing a piece of code can very easily verify if it actually works or if it doesn't. But with ML code, it doesn't really work that way. So you can have a model that actually works, but it can give out maybe wrong predictions or not good enough predictions. In addition, you have the quality of the data. If you have a sort of crappy data, you get a crappy model. So you have to have good quality data as well. And in addition, you have this, there's not really a one stack of services as you do with software development. You have different libraries, you have different algorithms, you try and check out different things, and there's no such thing really as a perfect model. There's always something you can do. And the problem often, as it really is in our experience, of course not with everyone, but with a lot of data science or analytics teams, is that there is not much mutual understanding across the teams. Meaning that if you have this arrow here, then you have raw data. You have a data engineer that's supposed to take that data, do something with it, and then just put it to a storage where a data scientist could pick up on it and model on it. You also have a developer that has made a application which is supposed to query the model, for example. And you also have operations, which is supposed to get everything to working together in production. And since statistical code is not the normal software code, the mutual understanding across these teams are usually a little difficult. Also, you kind of lose the control. So when the data scientists send over the model to operations, he or she doesn't really know what happens after that. So there are manual tasks and several teams involved here, and it's also these isolated processes. And this in terms was actually, or is actually, where software development and operations was before DevOps. So this is kind of our goal, to get this up to speed with the rest of the software development. So one of the problems with these silos is that the model actually works. From an ops perspective, the semantics is correct. It's giving out some sort of answers, but it doesn't really function well with real-time data. It can also drop in accuracy, for example, after a 3-month period, but no one really knows because you don't really have any control over it. So there you have a model running with flaws in production, which is undetected. I actually had a friend of mine that told me that she had a model in production for 6 months, which actually gave up the wrong answers or sort of bad answers, and it was not really detected. So the goal here is agile delivery of machine learning models. So it's sort of giving the data scientist the same benefits as the software developer. And in this is this self-service, as I told you about, that you can test and release on your own. You sit in control of your own model. You can also make more robust models because CI/CD actually gives you a possibility on testing on real-time customers, which I will tell you in a little bit. And also another key feature here is that you can control and monitor your model in production and how it performs. So how do we do this? Here's the traditional CI/CD, build, test, deploy. If we were to do this with machine learning, one way is to put a validation step. So here you train your model. It's the same, you do it in some sort of Git repo or wherever. And you build a container just like in software development, and you test it as the same, but you add a validation step. And there are several benefits of throwing this step in. What you do is you hard code logic. For example, what does it take for a model to be accepted? Is it above this and this percentage is only accepted and below is not? Is it like in an accepted area? I used to work a lot with banks and with loan applications. And they had very strict frames on how many applications would be automatically approved, and who should not. And then you had sort of like 50 to 60% that went straight to manual service with customer service. And if any of these sort of areas would grow and become a lot bigger than actually, if you have too many cases going to manual or yellow zone, then you will have a lot more work and a lot more stress on the customer service, and you will in the end lose money. So here in the validation step, you hard code what is an accepted model. When you push this through, if it's okay and if it checks out the validation step, it will be deployed to production. If it doesn't, it will fail. You will get an email, and then you can retrain it. So validation is usually something that data scientists also do when training, but putting it in this CI/CD pipeline has some benefits. Because what you can do here is that you can do this on a frequency. So you can, for example, say that every week at Wednesday at 12, you run this pipeline. So you do that the next Wednesday, you run the pipeline, and suddenly the validation step sees that the model actually has dropped in prediction, is actually dropped underneath the accepted area. Then you will be told. And this is a great benefit, because if this happens like in 2 months or 3 months, you will be told and said that, well, now your model is actually dropping. And if you have a lot of models in production, it is very nice to have this. And what another thing that's kind of key benefit is that you can have sort of a model competition, which in a way sees that the best performing model is always in production. So in the validation step, you sort of put, for example, 5 different regressions of algorithms, and you see, okay, which one of these actually gives out the best report or the best results given the new data coming in. And it will actually then, you hard code this of course, but it will then deploy the model with the best performance. And when every one of these drops, you will also be told. So this is a great way to, well, always know that the model is actually performing as you want, and also the point that you're actually getting the best model in production. So the benefits of this, and as I told you, there is another thing as well, because you have something called A/B testing, which is something software developers do a lot of. What it means is that you take, for example, 20% of your customer base, and you test your model on them before you deploy to the rest. So if you, for example, are doing a sort of a web shop and you want to see, you want to do recommendations based on what they're buying. If the first model you put to production gives out, for example, 30% more the customers buy 30% more, but your new model, they actually buy 50% more, which is kind of big, but anyway. And then you can decide that, you know what, this model performs a lot better, so I will just roll it out to the rest, or it performs even less good, so you will just roll it back and just let the other model take over. Another thing is that you will be notified, as I told, when the model actually drops below preset levels. And now we're coming into what Yngve is going to talk about. Because when you have this automated retraining of model with triggers, as I said, you could set this on, for example, a date or a time, but you can also do, for example, when there's new arrival of data. If you have sort of kind of a batch delivery data to your storage, you could do it whenever there's a new arrival. You could also have like when there's a certain gigabyte amount of data in storage, then train. But all this and an example on one of this will Yngve actually talk about now. So I'll just put over to you, Yngve. How do you actually get there in AWS?
Yeah, my name is Yngve Sandal. I am a cloud architect at Redpill Linpro. The goal here today is that we are going to view a code pipeline doing model training and deployment. Now, together, we will try to give you some background for this model and the use case. And to be able to do that, I have to say some stuff about data science, and I'm not a data scientist, so I would like to apologize on beforehand to anyone who is, for using potentially wrong names on terms and concepts. If there is actually any doubt to what we mean here, please notify us in the chat field, or and we will try to clarify as we go along, or potentially later on. Alas, we have not reinvented the wheel for this demo. A lot of companies are somewhat sensitive about how they use the data. Therefore, we are not showing a customer project here today. Instead, we are using an AWS workshop as a basis. For those who are not familiar with this URL, GitHub is a place you can find thousands of projects, and among them there are at least 1200 projects just for AWS, which can show you how to do whatever really. And we are building on a workshop called Amazon Sagemaker MLOps. This workshop will show you how to build this pipeline and explains how and why. Now, this workshop makes some assumptions, and these are taken from another lab. This is called Customer Churn Prediction with XGBoost. And that lab takes you through how to predict customer churn. For those of you who are not in on this slang, that is predicting which of your customers will become unhappy and leave, and who are going to stay. In this case, the example is a mobile operator for whom it's a lot cheaper to use incentives to keep a customer, like giving away a phone, than to lose a customer and try to acquire a new one. The dataset that we are going to use is free and open and can be downloaded by anyone. The URL to this will be distributed later on. It's on approximately 3000 records, so it's not very big. The algorithm we are using or being used in this project is the built-in Sagemaker algorithm that's called XGBoost algorithm. And this prediction project that we have been referring to here evaluated that of 48 churners, 13 was predicted. That's true positives. 4 were incorrectly predicted, and 9 churners were not predicted. Those are the false positives and the false negatives. And the initial cutoff was set to 0.5. That means that every value above 0.5 counts as a churn, and every value below as a stay. The predictions are values between 0 and 1. 1 is churn and 0 is stay. And they then made the calculation, guessing that a lost customer would cost X and customer incentives would cost Y, and ended up, after doing some complicated math, setting the cutoff to 0.46 to get the best results for these predictions. So this is the backdrop. So CodePipeline, what is it really? It's a continuous delivery service for fast application updates. It's a versatile brick-by-brick solution, both using AWS services or other, like Jenkins or GitHub. There are also several other building blocks to click into the pipeline. And the service mentioned here is often referred to as the CodePipeline stack. And it looks something like this conceptually. This is a typical development pipeline for CI/CD. Now, this is more of a real-life example. AWS code commit, receive a code update. Code build builds a new version or container or release. And code deploy deploys to what we have decided to set up our solution on. The examples here are EC2 instances, or a container service, or slightly hidden behind me, AWS Lambda function. I would also like to point out that at this time, for the sake of this demo, we are only showing AWS native services. Most pipelines would probably be a mix, and it's, for example, quite usual to use GitHub instead of code commit. So what possibilities does a pipeline, and here specifically CodePipeline, give us? Well, for machine learning workloads, versioning of artifacts includes standard best practices around versioning of code and containers, but also includes versioning of data, algorithms, and model artifacts. Quality gates by ensuring a minimum degree of model quality before introducing a model into production. This can include gates, like measuring the readiness to move a target to an environment, such as a model evaluation, system monitoring, and business impact evaluation. Automated deployments of your model for predictions ensures consistency and reliability, and automated retraining based on the strategy defined for your model is key in being able to prevent model drift and take advantage of new ground truth data. So that was some theory behind this. Now, this is the diagram is the pipeline that we are going to try to set out in life. It shows the environment and flow of the pipeline that we're going to look at. Now, this is not a very simple diagram, and optimally I would prefer to have this showing while going through the pipeline. But as that is not possible, the URL to this diagram is you can find on the top of the chat window, where you can click it and download it, so you can have it and look at while we go through the pipeline. So what is happening behind the scenes here that you do not see? We have everything built from CloudFormation templates. CloudFormation is AWS infrastructure as a code. We are using S3 to store everything that needs storing. Artifacts, Python code, notebook, etc. This would probably in real life be a code repository like CodeCommit, GitHub, or something like that. We are using a Jupyter Notebook, and usually this is where the training happens. But in this case, it is just used as a lab environment after the initial setups required for setting up the lab pipeline. We are utilizing a notebook instead of a local environment to ensure a consistent lab environment. The pipeline Lambda code is code that we will use for training and deploying our model using Amazon Sagemaker, and inference Lambda code, that is code that we will use for evaluation of the model by running predictions against it. And Lambda, for those of you who are not familiar with that concept, Lambda code is very simply put a bit of code that AWS will execute for you on request. For example, as in this example, Python code. Can also be a number of other types of code. Now, the kickoff of a pipeline could be set to happen on a diverse set of criteria. In our example, it is that files appears in an S3 bucket. It could also be a Git push from a repository, or simply a scheduled, for example, a weekly happening. This is all up to you and your needs, really, when you get your project going. The Jupyter Notebook we will show in just a little while. We will utilize this notebook to perform some of the setup that will be required to trigger the first execution of our pipeline. In this notebook, we are going to simulate what would typically be the last step in an analytics pipeline of creating training and validation dataset. To accomplish this, we will actually be uploading data from our local notebook instance to S3. In a typical scenario, this would be done through your analytics pipeline. We are using the S3 bucket created by the previously mentioned CloudFormation templates. So we are going to alternate between 3 different views in this demo. The CodePipeline dashboard, the Lambda Python code, and the CloudWatch log files. And in the end, we will also close with showing a terminal window test accessing the endpoint that we have set up. So I'm going to very quickly switch over to another view here. That didn't look too well. And we're back. So that's the pipeline, but we are first going to look at the Jupyter Notebook. A couple of steps here. The first step is just for viewing data. We are now going to utilize this notebook to perform some of the setup that will be required to trigger the first execution of our pipeline. In this notebook, we are going to simulate what would typically be the last step in an analytics pipeline of creating training and validation datasets. So here we see in the first step, and as I mentioned earlier, we have a dataset with approximately 3,000 records. Here these are split in 3 files, as we can see here: train, CSV, smoke test, and validation. The first one that is used to train the model is on approximately 2,300 records. The next one, smoke test, which is only used for a functionality test later on, is 10 records. And then the remaining records, approximately 650, is used for the validation run. So here we can see just the contents of these files, which will be used later. Next step is that we are actually uploading these files to the S3 bucket we have mentioned. This is happening down here. See these 3 commandos: S3 client upload file, and then train, smoke test, and validation CSV. This, again, as I mentioned, would typically be done through an analytics pipeline, and we are kind of cheating here with just manually copying these files into the correct bucket, with the result that the pipeline is kicked off. If you are with me so far, we will now then move over to the pipeline view. Now, the pipeline itself looks like this. So we have been cheating a little bit here as well. This pipeline has already run. Actually, we are not going to, for the sake of time, we are not going through the actual run through of this pipeline now. It would take about 35 minutes, and that would be a little bit long for this demo. So I'm just going to show and tell, and also then show you the result of the finished pipeline. When you first start and look at this pipeline, which has not run yet, all that you see here as green now is blue. So when the pipeline is run through for each successive step that is that finish as planned, it turns green instead. Unless something fails, it will turn red. So it's very, very visual. Unless you're colorblind, that is, then you will have to look at the marks over here instead. So the first stage here is called source. The pipeline is split into different stages. Actually, this is the stage number 1, this is stage number 2, and so on, and each stage have different actions. So the first stage of this pipeline has one action, and it's called source. So no actual code is executed here. It's just CloudWatch checking for the existence of files in that S3 bucket we mentioned earlier. And now we have just used the notebook to copy those files into the bucket, and that means that the pipeline will kicked off. So at once that it sees these files, it will be marked as succeeded, and it will hand over the control to the next stage, which is called chain model. The name kind of gives away what happens here. As we see, there are two actions. It's start training and get training status. This is also rather self-explaining names. We'll take a look at what happens inside start training. Now we will actually be looking at the Python code for this function. Not all of it, of course, but the important steps. If we go down to line 38 here, we see that the create chaining job function is set off. This is where create chaining job is kicked off, and we see that here is its definition, and the create chaining job is where a lot of parameters is set. And then if we go down to here, we see that we have a function called create training parameters, and then it all culminates down here where the magic is happening. Sagemaker is being told to create a training job with the specified training parameters that has just been set. Main points from the Python code. If we then look at details, we will then see the CloudWatch log of what was happening. So what actually happens here is that we see that training starts and at point of time with these parameters, these algorithms, these kind of virtual machine and so on, and the instance type and so on down here, and we see that the job information is written to S3 success training job started. Okay, so the CloudWatch log has reported success. That means that in the pipeline, the start training action will hand over control to the next action, get training status. What's actually happened here now is that the Sagemaker runtime has been provided with all the necessary data to train the model. Get status is actually not doing very much. It's just probing Sagemaker continuously for information on when the training is done. And we finally get a success with the message that the model is trained and moved to the correct S3 bucket to be ready for the next stage. This message then comes from Sagemaker. We can take a look at that here. So if you see, this is a rather long log, but if you can see here, there's a lot of repeating segments, which looks like this: start, request ID, and deployment status is creating. The status is still in creating, putting job continuation. Endpoint creation is still in process. And this goes on and on until we get down to the bottom here, where it says the deployment status is in service. Endpoint is in service, putting job success. Deployment completed. Very good. That's what we wanted to hear. So back to the pipeline. That means that the last action of this first stage is done and control is handed over to the next stage, deploy model dev. And this is where the model is deployed to an endpoint in the developer environment. We'll take a look at the Lambda code again. As previously, we will not be looking very deeply into it, just try to pinpoint the main action points. We take a look here at line from here on and down. There are some explanatory comments, and we're doing a test. If endpoint environment equals dev, which means if we are in the dev environment, and we are, the function create model is run. This will create a container containing the model and artifacts created during the training and make it available for us. If you are unfamiliar with the container concept, that's no big deal. The takeaway here is that deployment job get access to the previously created model. A little bit further down, create endpoint config. This is where we put together the configuration for this endpoint. And here, create endpoint with said configuration. So back to the pipeline. We'll take a look at the details here. We can see that we have endpoint environment dev, creating new endpoint configuration and creating endpoint, and we have here success endpoint deployed. So everything is good. We go back to the next step, action that's called get deploy status. This is just then waiting for the status for this. It does what the get training status did appear, more or less. It waits for that success message we just saw, and when it gets it, it hands over control to the last action, which is called smoke test. Smoke test is kind of a strange name maybe, but it's just a functionality test for the endpoint, that it does what it's supposed to do. So if we look at line 45 here, it says if environment is dev, which it is at the moment, we will use this part of the dataset, smoke test.csv, which the one that you remember is just the 10 lines. And then we see here that we are starting a loop for row in CSV data. That means go through all the rows, all the 10 rows. And for each of these rows, we are doing this. We are runtime client invoke endpoint. We are telling Sagemaker to invoke the endpoint with the row of data, with the one record from that file. So it's just this will just loop 10 times then. It's just to see if it's working. So we'll take a look at the log from smoke test to see what it says. And here you will clearly see those 10 files looping over and over, you see here that there's a similarity between, if you take a look at this, row to format, row on input is, and then the formatted values that are sent to the endpoint. And we have some communication going, and then the message is prediction processed, actual response is 0.05 blah blah blah. This is then very close to 0 as we see, and the prediction is set to 0. So the only thing that's actually tested here is that there is a prediction, nothing more. We don't care too much about the actual values here. It's just to see if it's working as expected. Success here in the pipeline is measured on the fact that prediction values are returned at all, nothing else. So when this then meets the success, we are handed over to the next stage, which is deploy model test. So as you can see, deploy model tests and deploy model dev is quite similar. The only real difference here is that the test is called full test instead of smoke test. Otherwise, it's more or less similar. The implication of this are that the same Lambda Python code is run, but with somewhat different parameters. With the environment variable now set to test instead of development, another data file is opened. This with 650 records instead of just the 10. And this time the prediction value is of importance. We will take a look at the Lambda code for the test. Now if you go down here to line 168, you can see here that the cutoff value that I mentioned earlier is hard-coded to 0.46. And now then I get down to the tests. If the predicted value from the previous function is yes, it's testing against the response cutoff, which is set here, 0.46. If it's greater than 0.46, it's set to 1. If else, that means if it's lower than 0.46, it's set to 0. So we end up with either 1 or 0 from the function. In this example, these values are printed to the log file, but not used for anything else as such. So at this point here, it's up to the user to add some Lambda code where to collect these and write them to a file, or use them, write them to a web page. Let some business intelligence tool like QuickSight acquire it, or actually use them for something functional. This is also would be a perfect place to integrate more test functionality that would return us to a previous step in the pipeline to retrain the model if we are not happy with the results. Just like Mia showed earlier on the slides. This then does not have that included, but that would be a simple step to put in here. Now, with the reported success of full test, control is headed over to the last stage, which is deploy model prod. This is the final step. It also has certain similarities with the previous stages, but as we see, it lacks the final step. There is no test here. The same function as in the earlier stages deploys an endpoint, this time to the production environment, but then just leaves it there. The endpoint is now ready for use by your application of choice, whatever your need may be. There is a get status here in the end, but this is just measuring the success of the deployment of this endpoint and nothing else. So the end result here is that we have an endpoint in AWS that is ready to be sent values and then predict churn or not churn from that. To try to exemplify this, I will show you a very small script run from the terminal on my computer that will access this endpoint and run a prediction for one record. And hopefully we will see a response from the endpoint that makes sense. So to just show you that we are actually using kind of live data here, I'm going to switch over to the Sagemaker dashboard. And see what endpoints are activated. And as we see here, we have 3 endpoints. Just as we said in the walkthrough of the pipeline, we have a production endpoint and the test and developer endpoint. This is then the endpoint we're going to access. So I have taken the name of this endpoint and put into the small script that I made, which we will now take a look at. So very easily explained for those of you who does not read script. Here I am setting the variable endpoint name, and this is the name from Sagemaker that we just saw. I'm then running the command AWS Sagemaker runtime invoke endpoint, which, as you probably understand, means that we're telling Sagemaker to invoke the endpoint with this data. It's called the body of the command. Now this looks like a lot of gibberish, but this is actually one line, one record from, if you remember this data set, the training data. It's a randomly picked line from this file. The reason it looks like it does is that it is base 64 encoded to work from the terminal. And then the last point here, please put this in this file. So now I'm going to run this, and hopefully in a few seconds we will get a prediction value back from the endpoint. And lo and behold, we got an answer. The prediction value for this record was 0.0395. So again, rather low one and close to 0. So what does this all mean? The ability to have an endpoint that one can access and ask for prediction is a functionality that kind of speaks for itself. It can be very valuable in a lot of different setups. We have mentioned some more things we can do with CodePipeline here. The example we have been through is rather simple, but there is a lot of more functionality we can put in. Not least, what we just saw by accessing from a terminal is not very functional in the real world. What we probably would do would be to create an API via the API gateway in AWS to be used for prediction, because then we can use access it programmatically and write applications that can access this. So that's all from the demo corner today. Thank you for being with us on this demo.
Okay, thank you, Yngve, and thank you all so much for watching. We will shortly send you an email with the URLs and also with the presentation, and with that you'll also get our email. So if you have any other questions, then please feel free to ask us anything. Well, I think that was it for now. Thank you, and hopefully we can do this again.